Hey, how's it going, guys? Welcome to Solidity with the Cryptoverse DAO. I'm your host, Dharma Sutra, or BKLYN, the God, whatever you want to call me, man. Dharma. How's it going? Hope you've had a good day. We are going to cover a brief introduction to Solidity. We have a lot of educational content. I should give you all the YouTube stuff about like, comment, subscribe, but I don't want to waste too much time. So you know about all this great stuff. You know about the content that we push out every day. If you like it, engage with it. Let's start with a what. I'm gonna go through a what, a who, and a how. And in the course of that, we will talk about why, as well. But very, very high level overview. Solidity is a programming language. It's a programming language that is focused on designing and implementing smart contracts. It's influenced by C++, JavaScript, Python. It's a high-level programming language, which means it's quite accessible, quite easy to pick up and use, even if you are not familiar with coding. Solidity was literally my first programming language, and it was quite accessible. The barriers to entry were not as high as the barriers to entry to other lower-level programming languages. And it is a high-level programming language designed to allow you to design and implement smart contracts with a specific orientation for EVM. You see EVM orientation on here. That is the Ethereum virtual machine. It's a runtime environment, and we'll get into all of that great stuff in just a minute. So it is object-oriented as well, but when I say it has a specific orientation for the EVM, the way the EVM is structured, right? You have a stack. This is something that you see with any runtime environment. You have a stack. The EVM also has obviously memory and storage in addition to the stack. And there's calls to and from stack to storage, storage to stack, or memory, depending on what it is you're trying to do. There's a program counter, and there's a gas balance. That's something that you will see in the EVM. So the language is pretty much oriented to take all of these components into consideration, I suppose, and work as smoothly as possible with all of these components. So with transacting things, the way it would work is it's on a smart contract, which we've covered in depth in a different educational episode, I suppose, but it's worth giving you a higher level overview, I suppose. So a smart contract is effectively, think of it this way: everything is governed by code. The reason that your phone works the way that it works is because when you press the power button, there is a piece of code within the phone that is executed. As soon as there's an input from the button, it runs or executes this specific command or series of commands in order to wake up the phone screen and present you with that user interface that you see. There's a back end and there's a front end. Now, a smart contract effectively does the same thing as regular code. It will execute a command, but a smart contract is different. A smart contract is unique because the execution of that the execution of that command is dependent, it's contingent upon the fulfillment of preset or pre-specified conditions. There needs to be the fulfillment of conditions set out in the smart contract in order for a successful execution of a command or a transaction to occur. That is what a smart contract does. It eliminates the element of trust. It's conditional, right? That's what a smart contract does. And it's extremely, I suppose, reliable is the word. Yeah, reliable is the word. Because as long as the preset conditions have been coded well and make sense, you have that assurance that there is no way in hell that anything could go wrong, that anything could be tampered with, or and any of that stuff. It can't happen because the execution of that command is dependent on consensus being reached. Consensus among nodes in the Ethereum virtual machine sort of network, in the Ethereum network, on the blockchain, as it were. Each node needs to reach consensus, basically come to an agreement that things make sense on both sides of the fence. That's a pretty simple way of thinking about it. And beyond that, I mean, even within Solidity, like as a language, I mean, think about the way that a transaction is called, right? So a transaction would call a function from a contract. The stack items are stored in memory storage. Data from storage or memory can be added to the stack. It's like a two-way process, but then every node needs to effectively reach network consensus. The pre-transaction state needs to be in line with the post transaction state, the projected post transaction state. If that consensus there is not reached as well, it doesn't happen. The transaction or the execution of that command does not happen. It's impossible. That's just the way that Solidity as a programming language is built. And what does that mean? How it's built? We'll get into detail about that in just a second. Before that, I want to talk about who kind of created this. So Gavin Wood, absolute fucking genius, guy from the UK. This guy was one of the primary like founders of Ethereum. And Christian Reitweisner, we got all of these guys were the core team, pretty much the core team of Ethereum, and they all contributed towards this, the creation of this programming language. If you read the Ethereum yellow paper, I think that is the best way to kind of gauge what they were trying to, what they set out to achieve. In essence, I would say my understanding of it is expanding beyond the singular utility of Bitcoin, which is transactional utility. That's all that it does. It's just a transactional token. Moving beyond that, and allowing people the ability to basically create anything, an application, a decentralized application, DApp, right? DApps. This is something that you'll hear. They're built on smart contracts, and it's effectively a means of transplanting the transparency and the reliability of the blockchain framework upon which that transactional utility of Bitcoin operates, transplanting it into a secondary blockchain, like a secondary system or a secondary, let's say, environment, right? Not in the runtime environment sense, but just in the kind of holistic sense, transplanting it into a new environment in which people can create infinite utility, like the same sort of reliable, transparent framework, but this time used to create a move to earn token or to create a project in GameFi, or just anything, man. You could create a version of Tinder on blockchain. I'm surprised no one has done that yet. Yeah, boy, I just gave someone a terrible idea. But yeah, literally, like you could do anything, everything that you use on your phone right now. Literally, if you have an iPhone right now, just don't even hit the power button, man. Like if you orient the phone to face the phone screen to face your face, what happens? The screen wakes up. That is the result of an execution of a command based on, there's an input, right? So the gyroscope within your phone says that it's been oriented this way. The infrared sensors read that there's facial, something face looking being registered on the infrared sensor in the camera. And so with those two pieces of information, those two conditions met, what does it do? It executes the command, turn on phone screen. It's very, I'm sure that's not the exact specifics of how it happens, but if you think about it, that is, basic high level overview. That is how any application or any functionality on a piece of technology works. What's the difference? That is open source. It can be messed with. A smart contract cannot be messed with. A smart contract works on, so there's the execution of a command, right? With a smart contract, it's not based on it can be based on an input, I suppose. But what a smart contract does that is different, right, is that it's fully dependent on those conditions being met. If those conditions are not met and something called consensus is not reached, then, it just does not run that command. The execution just does not happen. There's no, bugs could occur, but at this point, this is what the kind of value is, I suppose, of using Solidity, using smart contracts to govern the way that things work. Because think about your phone. Apple could technically access. It's not as simple as the transactional kind of utility. It's things like storing your data. If your data is stored on a blockchain, there's full transparency and there's full kind of reliability, because if you go in and you set the conditions beforehand to say, hey, it's only in the event of this that your data can be used, or accessed, not even used, but just accessed, or data cannot be viewed by these specific parties or something like that. Just as an example, doing that on a smart contract gives you like 100% assurance that your pre-specified conditions will not be broken, and have the execution of that command still happen. That can happen with regular code, with regular coding languages that aren't on smart contracts, right? The analogy that I like is you can draw the same picture on a whiteboard, like a dry erase board. You could draw the same picture, but you could also carve that picture into stone. You could carve it with a chisel and a hammer, carve the same picture into stone. Same exact picture. And you tell me which one you would trust to kind of throw out into the world and ensure that your message or the picture is not diluted or abused or used incorrectly or misrepresented or just mutated, right? You tell me which one you would prefer. I know that I would prefer to carve something into a piece of stone, chuck it at someone's head. Well, maybe not chuck it at someone's head, but just chuck it into the world. And, I know that my message is not going to be misrepresented. I know that my code is not going to transact or execute prior to the fulfillment of preset conditions preset by me, which I trust, right? So that's how it goes. That's kind of like the utility of what I suppose these guys were trying to accomplish. But don't take it from me. Take it from the horse's mouth. Take it from the coder's mouth. Take it from the Ethereum white paper. Google it. Just Google Ethereum not white paper, yellow paper, and you will find the document. Go through it. Read it. It's fantastic. Also, if you haven't, read the Bitcoin white paper because it's fucking next level. Really, really cool. Now, with Solidity, obviously you need to have a runtime environment. And you need to know what value types are supported, what variables you can use, and it's important to talk about the use cases as well. All of these are constantly being added to, the use cases, I mean, because like I said, infinite potential. It's basically, if you have an idea that is dependent on a yes or a no, if you have an idea that's dependent on things happening in like a coding sense, in like an execution of commands type sense, then you can put it on a blockchain. You can absolutely put it on a blockchain. Anything that exists now can be put on a blockchain, but also things that don't yet exist can also be created for blockchain technology. And again, these are all, I mean, this is just a high level overview of the ways that you can set up your environment. I think it would be best, in the interest of time and people's concentration, if we put this on a specific episode, so that I can like maybe screen share and walk you through the creation of a very basic smart contract with maybe just a simple, maybe just like data storage, like just storing an address and recalling the address or something like that. I think that's a pretty good idea. Yeah, it's tough to explain without visualizing. So we'll have that prep for a secondary episode. But let's talk about value types in the meantime, right? Solidity supports booleans, integers, fixed point numbers, pretty much anything that is a supported value type across C++, Python, JavaScript. You would most likely find in Solidity, you most likely would find that Solidity supports this as well, because it's heavily influenced by those three programming languages that I mentioned before, which means if you are a JavaScript programmer, or you know about Python, or you know about C++ and just a basic kind of at a basic level of understanding, you're going to find Solidity extremely simple. It's already one of the easiest programming languages to pick up. Like I said, I think I mentioned this in this episode, it was my first programming language. It's really not that difficult. And if you have that previous kind of context, then yeah, you will find, so integers, booleans, fixed point numbers, addresses, obviously it's like 20 integer addresses for Ethereum. You've got enums, you've got rational and integer literals, contract types, fixed byte arrays. Again, I mean, I could go into each of these things in depth, but I think it would be worth it to, in order to make sure that you understand the way that these things are used as well. It would be best to kind of have it visually represented for you. In the interest of that, I think there's like a deeper kind of an expansion of each of these value types in the Medium article that is attached to this specific video. But just, I mean, I talked about booleans. That's basically just a way to attribute a true or false value to something. Addresses, pretty self-explanatory. Integers, signed and unsigned. Default 256 on Solidity. That's the byte size for default integers. You could have like an 8, like a uint 8, an unsigned integer 8, or a signed integer, which would be int 256. Like you could have signed and unsigned up to 256. The standard is 256, excuse me. You can have string literals. They imply trailing value zeros. You could have modifiers, which ensure the fulfillment of predefined conditions before code execution, mappings, and those are like generic value types. Those can be kind of expanded upon, extrapolated to, or just continually, expanded upon is the word, to develop more complex data types as well. Which, again, it's really no use kind of breaking these things down unless you can, well, I suppose there is some use to it, but the best, most effective way to learn how to use these things would be to watch someone use these things. So in the interest of that, I think what we will do is probably do a live session sometime next week, wherein I will load up just from scratch, right? Just like Gavin Wood did on that one conference where he had a shrink wrap MacBook Pro. I'll download all of the kind of dependencies that are going to be needed. So Node.js, and then like I'll need Truffle. I'll need like a test net on which to deploy a smart contract, and basically I will guide you through the process. Yeah, I will set up the environment, and I will code a smart contract, and I'll talk you through each step of the way. So like if I'm using an integer, if I'm using I'm gonna start off with progma solidity. What does that mean? What does progma mean? Why solidity? What are the numbers right next to progma solidity? 0 point something something something. What is that? So I can explain to you. Progma is defining the programming language. Solidity is the programming language. The numbers are the version that you want to use. Why would you use different versions? Is it worth it? Isn't it best to just use the most up-to-date version? Sometimes no, right? And why is that? So we can go through that step by step. I think that's a pretty good idea. So let's talk about variables as well. You've got state, local, and global variables. So state variables are variables whose values are permanently stored in a contract storage, right? You've got local variables. Those are variables whose values are present until the function is executing. And then you've got global variables. These variables, they exist in the global namespace, which is like the entirety. So I talked about a runtime environment. A global namespace is like the entirety of the project, like where it's like the most macro view of an environment which contains all of the files and all of the information. So this would include everything from the smart contracts to the Ethereum virtual machine to the friggin' just everything, right? All of it. Like those global variables exist and are applicable to the entirety of what you're trying to do. A local variable, contract specific, right? And a state variable, contract specific. Local variable, literally just present until the function is executing or has been executed. As soon as the process of execution begins, it's gone, because it exists to fulfill that function, the execution of that function, if that makes sense. The next thing that I wanted to cover, basically, use cases, man. Absolutely endless. Like I've said before, anything that can be anything that can be done with code can be done better with code on a smart contract in a more reliable, more transparent way. We've seen the United States Air Force trial blockchain technology as a means of cutting down on wastage of money, like monetary wastage, which is crazy. It's literally efficiency, man. It's like cutting down. Think about Salesforce and why it's one of the biggest, like so much freaking money as a result flowing through Salesforce, but also as a result of Salesforce. And what does it do? Streamlines things, right? Blockchains streamline things, man. It's like so fast. It's because it's computers talking to computers, and it's so reliable because as long as the human is only there to set the terms of the smart contract, and during my lifetime, we're gonna see that if I have anything to do with it, we certainly will see it. Literally, AI, machine learning, will pretty soon be coding the smart contract, like setting those conditions. It won't even be humans anymore. It'll be advanced machine learning algorithms coding smart contracts, which then execute code at fucking light speed, to kind of give you infinite scalability, absolute transparency, and complete reliability. That is the way, by virtue of a blockchain, just putting anything on a blockchain attributes those attributes to to it, right? But in the sense of like making this make sense, I mean, think about human resources, think about banking, think about financial services, trade, data storage, data processing, everything. Like Solidity can serve in banking as a tool to create smart contracts that can increase the transparency of transactions and increase the speed of said transactions at the same time. No more shady business in finance, never again. It's all crystal clear. It's all transparent, and it's all in way faster, way faster. Upgradable contracts, the method of assigning calls pointing to another contract containing the actual business logic, can help in upgrading contracts. Trade and finance helps in reducing risks while ensuring faster execution. What does that do? Just a whole lot of great stuff. Data storage helps in separating logic and data in various contracts, smart contracts, which can act as a storage space for valuable information. And digital identity, Solidity-based smart contracts could help in resolving identity theft issues, and could allow for the secure storage of credentials. Can't get more secure than a smart contract, to be completely honest. So yeah, it's those three target areas is what I'm seeing, like security, transparency, and efficiency. It's those three target areas. That's what putting things on a smart contract brings to the table. Now, with all that said, I think that's a pretty good introduction to Solidity. I do apologize if it's a little bit all over the place. This is the way that my brain functions, man. But if you want to, see my brain in action, do join the Discord, and let me know that you're interested. If you are interested, then I will do a live session, and we can literally just go through it together, and you can, any questions that you have, just bring them to the table, man. We'll do a live discussion. Follow us on Twitter, follow us on all of our socials. Literally just scan this. It'll take you to our link tree. You decide how you want to engage with us, man. If you prefer live sessions, hop on Discord. If you don't know what a Discord is, join us on Twitter. Wherever you operate, we probably have a presence there. The Medium is really good as well. You can just take in all of this information in your own time. But yeah, enjoy. Take care. Big love. I've been Dharma. Bye-bye.